Hi, good morning. In this session, we are discussing some problems regarding same topic, transformations. In your textbook, open the page number 3.50, and here in this session we are discussing question number 7, 8, 9, 10 and 11. Questions 7, 8, 9, 10, 11. These are the questions today we are discussing. Before going to the problems, let us recall all formulas. In our previous session we are discussing about them. Sin c plus sin d, 2 sin c plus d by 2 cos c minus d by, right? Okay, just take few minutes and recall all those formulas. Okay, now look at question number 7.1. The question is a plus b plus c is equal to 180 degrees. Then prove that cos 2a plus cos 2b plus cos 2c, sorry, this is minus 2c, cos 2b minus cos 2c is equal to 1 minus 4 sin a sin b sin c. 4 sin a sin b and cos c. Okay, so to prove this result we have to recall our earlier discussions, that a plus b plus c is equal to pi implies a plus b equal to pi minus c. Okay, write down here a plus b plus c is equal to pi. Okay, and take LHS as same as our previous problems. The LHS is cos 2a plus cos 2b, cos 2a plus cos 2b minus cos 2c. Okay, so this is equal to, remember the formula, cos 2a plus cos 2b. So cos 2a plus cos 2b is cos 2a plus cos 2b, it is looking like cos c plus cos d, right? Cos c plus cos d is equal to, cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2. Got it? Right? So now let's picturize this 2a as a c and 2b as d. Then according to this formula, c plus d by 2 into cos c minus d, c minus d by 2 minus cos 2c. Okay, how do you understand this step? This is c, this is d. C plus d by 2, c minus d by 2. So calculating this fractional value, what you will have? A plus b. Okay, because this is 2a plus 2b. 2 is a common factor here, so you can take that out. 2 of a plus b, 2 and denominator 2 cancel, so a plus b. And here cos of a minus b. The same type of calculation. Instead of plus here it is minus. So minus cos 2c. Keep this term same. And here, look at here, a plus b. So instead of a plus b, you can write pi minus c. Why? Because a plus b plus c equal to pi. A plus b equal to pi minus c. Just substitute here and keep that remaining terms are all same. Minus cos 2c is equal to how much this value? How much is this value? Cos of pi minus c. Pi minus c is a second coordinate. Cos is negative there, and pi is an angle, so cos will occur. So minus 2 cos c. The value of 2 cos pi minus c is minus 2 cos c. 2 cos of a minus b. And now you have to represent this cos 2c. This one you have to represent this cos 2c as cos 2 theta. Picturize that cos 2 theta to cos square theta minus 1. I already give 3 types of results for cos 2 theta. One of them is cos square theta minus sin square theta, 2 cos square theta minus 1, 1 minus 2 sin square theta. Of all these 3, here the required result is 2 cos square theta minus 1. Why? Because here the angle is you have to express this value in terms of cos c's. So write down here 2 cos square c minus 1. Now this is equal to, take 2 cos a as a common factor. So what left here? Cos a minus b. Okay, already it was taken. So how much is there? Just cos c, right? Just cos c here in this term. It is minus 2 cos square c. Minus 2 cos c is already taken out as a common factor. Minus is also already taken, so plus 2 is already taken. One of cos c in cos square c, 1 cos c is taken, so cos c is there. And minus of minus is plus 1. Okay. Now this is equal to minus 2 cos c, and you know here cos c, instead of cos c you can directly write as cos of a plus b minus cos of a plus b plus 1. Okay, I will show you why we are taking that. Here a plus b plus c is equal to pi, right? A plus b is equal to pi minus c. Take apply cos function on both sides. So we have cos of a plus b equal cos of pi minus c. So cos of a plus b is equal to, this value is minus cos c. So whenever cos c occurs, substitute there minus a cos of a plus b like this here. Okay, got it? Understand? Now minus 2 cos c of, and how much is this? 2 sin a sin b. 2 sin a sin b plus 1. Next one, how much is this? Minus 4, 2 2s are 4, minus 2 sine A sine B cos C. This is RHS of the problem. Okay, just copy all these and look at this problem twice. If you have any doubts, just play back one more time, play back and swipe and play back. Next problem, 7 2 7 2. If a plus b plus c equal to 180 or pi, prove that sine 2a plus sine 2b minus sine 2c equal to 4 cos a cos b sine c. This is the result we have to prove here. This is most important question. So many times it is asked in the public examination. Sine 2a sine 2b minus sine 2c. Let us discuss this. So first take LHS. Sine 2a plus sine 2b minus sine 2c. Okay, first of all, here where we have to remember a plus b plus c is equal to 180 or pi. Sin c plus sin d is equal to how much? Sin c plus sin d. Sin c plus sin d, here we are using here this formula. You have to picturize 2a as c, 2b as d. So 2 sin c plus d by 2 cos c minus d by 2. Okay, here we are using that result, 2 sin 2a plus 2b by 2 cos 2a minus 2b by 2, and sin 2c means 2 sin c cos. There is no restrictions for sin angle, just directly write that. But in for cos you have to observe what here happening. Okay, in cos terms we are not presenting direct formula here, it depends upon the first term. Okay, in previous problems you can understand this. So while after calculating what this step would be reduced to is sine of a plus b into cos of a minus b, and this is minus 2 sin c cos c. So here we structure here. So just here we are calculating that a plus b is equal to how much? A plus b is equal to 180 minus c, right? So take sine function on both sides. Sine of a plus b is equal to sine of 180 minus c. That implies sine of a plus b is equal to 180 minus c is second quadrant. Sine is positive there. 180 the same trigonometric function occurs. So sine c. Here it is the standard result you have to remember up to the end of this problem. So sine of a plus b means sine c. Okay, substitute here directly, and cos of a minus b. Here write the same one, 2 sin c cos c. look at these two terms. 2 sin c is a common factor here, so take that common factor as a and what left here, cos a minus b and minus cos c. Okay, and 2 sin c cos of a minus b, same term, minus cos c means minus cos a. If you take a cos trigonometric function both sides in this step, what would be happen? So what happen? A plus b is equal to, we have 180 minus c, right? Taking cos function on both sides, cos of, okay, so cos of a plus b is equal to, here the result would be minus cos c. So minus cos c means you can directly substitute there cos of a plus b. So all these rough work shown besides this sum, you have, okay, understand? Yes, these rough work also be shown as a solution in the answer sheet. Got it? So cos a plus b. Okay, now 2 sin c of cos of a plus b plus cos of a minus b is how much? 2 cos a cos b. Now here it is the result, 4 cos a cos b and sin c, RHS, right? Understand? Copy this and understand this. Next, third sum. Seven, 3. A plus b plus c is equal to 180 degrees. Sin square a plus sin square b plus sin square c. Sin square a, sin square b, sin square c is equal to 2 plus 2 cos a cos b cos c. Okay. Okay. Now here also a plus b plus c is equal to 180 degrees. So take LHS, sin square a plus sin square b plus sin square c. Just change this sin square a as 1 minus cos square a and keep that remaining term same. Why I am changing like this? Because we have a result, cos square a minus sin square b equal to cos of a plus b into cos of a minus b. Okay, look at here. We have to use this result here in this steps to solving this problem. So the pattern is cos square a minus sin square b, but here there is no cos term in the given question. So why don't you change this first term in terms of cos's? So that's why I am using this result 1 minus cos square a. Get it? Next, take minus as a common factor. So this become cos square a minus, for these two terms only, for this first two terms only, you can take minus as a common factor and leave that last term same, sin square c. 1 minus of, here you can use this result, cos of a plus b into cos of a minus b. Write down cos of a plus b into cos of a minus b plus sin square c. Okay, so this is equal to minus cos of a plus b is now, since a plus b plus c is equal to 180 degrees, a plus b is equal to, right, 180 minus c. Apply cos function on both sides. Cos of a plus b is equal to cos of 180 minus c. So cos of a plus b is equal to, this would be minus cos c. So minus cos of a plus b become cos c, right? Cos c into cos of a minus b, cos of a minus b. Plus sine square c. Okay, now, okay, one thing we can do here. Why don't we write this cos square c also as 1 minus cos square c? We have trigonometric relation, no? So look at here, 1 plus 1, how much? 2, plus, take cos c as a common factor. Here in these two terms, cos of a minus b, here minus cos c, right? I just take that cos c. 1 plus 1 is 2. Okay, remaining terms 1 plus 1 is 2. Remaining two terms is there. Cos into cos of a minus b minus cos square c. These two terms have cos as a common factor. So take that out. So what left here? Write down. Minus cos c means cos of a plus b. 2 plus cos c, cos of a minus b, minus cos c means cos of a plus b. So this is equal to 2 plus cos c into, this is 2 cos a into cos b, right? Cos of a plus b plus cos of a minus b. Now the result is 2 plus 2 cos a, cos b and cos c, which is RHS. Okay. Next sum. Seven 4 a plus b plus c, a plus b plus c is equal to 180 degrees. Then sine square a by 2 plus sine square b by 2 plus sine square c by 2 is equal to 1 minus 2 sine a by 2 sine b by 2 sine c by 2. Okay, here it is, the problem. Right, take LHS. Sine square a by 2 plus sine square b by 2 plus sine square c by 2. The same result in our earlier problem we already used it there. Cos square a minus sine square b. Here I am presenting. Cos square a minus sine square b equal to cos of a plus b into cos of a minus b. Excuse me. Here write sine square a by 2 as 1 minus cos square a by 2 and keep remaining all terms same, sine square b by 2 plus sine square c by 2. This is equal to 1 minus of this step can be written as cos square a by 2 minus sine square b by 2 plus sine square c by 2. So here use this result, then it becomes cos of a by 2 plus b by 2 cos of a by 2 minus b by 2, that's it, plus sine square c by 2. 1 minus of, here given that a plus b plus c is equal to pi, right? A plus b is equal to pi minus c. A plus b by 2 is equal to pi by 2 minus c by 2. So apply cos function here. So what happens if cos a by 2 plus cos of a by 2 plus b by 2? Here take cos function both sides. Cos of 90 minus c by 2. So cos of a by 2 plus b by 2 equal to, this is sin c by 2. Why? Because 90 minus theta, first quadrant all trigonometric functions are positive. 90 occurs, then trigonometric function automatically changes itself, so cos becomes sin c by 2. So the result here is sin c by 2. Sin c by 2 into cos of a minus b by 2 and sin c by 2. Sin square c by 2. So 1 minus, take sin c by 2 as a common factor. See what left? A by 2 minus b by 2 or a minus b by 2, whatever you want you can write there, and minus sin c by 2. Okay, so instead of sin c by 2 you can directly substitute there cos of a by 2 plus b by 2 here. Okay, so this is equal to 1 minus sin c by 2 of cos of a minus b by 2 minus, right, minus there instead of sin c by 2 here, from here you can substitute cos a plus b by 2, cos a plus b by 2. Okay, so 1 minus sin c by 2, here the result would be 2 sin a by 2 sin b by 2. Here you can understand that imagine a by 2 as capital A, b by 2 as capital B. So cos of a minus b minus cos of a plus b, it is in the format 2 sin a sin b. A means a by 2, b means b by 2. Now the result is 1 minus 2 sin a by 2 sin b by 2 sin c by 2, which is RHS